We are going to start a new topic that is your searching and sorting of the arrays. So last week actually we discussed about the arrays in C++. So arrays is a array is a data structure in C++, and it is kind of it is like this. Suppose and there is an array named ARR, and it looks like this. You denote it in this way, putting a square bracket. You can specify the number of elements in the array here, or you can keep it blank, and then you can you have the data structure something like this. You have you have multiple segments there. I'm talking about the memory, and you store different elements of the array in between these shells. And why array data structure is so important, because this is a simple data structure. You don't have to you don't have to work very hard in order to define an array. So let's say you have integer array of 5 elements, and you can define it in this way, very simple. One, sorry, one, two, three, 4, and 5. So that's your array. Uh, Now today, actually, we are going to study the searching and sorting of the arrays. Uh, as we have done during our last session, we will be doing some discussion, some illustration based on the knowledge that is, the description given in the book. And we will also do some hands-on coding in the class. I will be demonstrating you how the searching and sortings are done using some examples. And of course, the examples are from the book only, so that you are, what I want you is that be familiar with the book and just go through different exercises that are given in the book and do the practice. Whenever you do the programming, practice is the key, and problem solving is the key. You have to be hands-on. Just by listening to certain description, or just by reading something, you will not be able to learn a lot of things. So that's our goal, to be very hands-on, so that after this class, as soon as you are out of this class, you should be able to smoothly migrate to your next destination. Maybe some programming, another programming class, maybe the data structure class, let us say. I'm just giving example. Or maybe you will start your new programming job. So that we want the transition to be smooth, and if you are hands-on, it will be really smooth. Not that you will be asked to do C++ everywhere, but C++ is important language, because this forms the basis of object-oriented programming. If you learn C++, believe me, you will be able to learn any language, whatever they offer, whatever complexity they present to you. C++ is the absolutely fundamental language, and let's try to focus. So when we talk about the searching algorithm, so first part is the search algorithm. So when we say the search algorithm, so what is search? Search means, like, you have you have an array, right? Like this. So in that array, you have to locate an element. Let's say you have 1, 2, 3, 4, 5, 8, 10. There are multiple arrays out there, multiple elements out there in the array. You have to locate 4, right? So you have to search for 4. So that is what is meant by searching. And we will be, to be honest, there are many searching algorithms, but we will be doing only the linear algorithm, linear search, and the binary search algorithms in this class. So if you understand the linear search and binary search, I believe that you will learn a lot, because all the standard search algorithms that you will be you experience, they are mostly based on either linear search or binary search. There may be some advanced search algorithms as well, but we are not going to discuss about those. So let's go to the linear search first. So this is a kind of sequential search, that is like you have an array of numbers, and then you search by the sequence. You visit each of the elements of the array, you find those, identify that yes, this is the number I'm trying to find. Once you find it, you stop the searching, and that's your linear search. So you start with the first element, that is the key. Then this algorithm, what it does, it goes through the, it steps through the elements of the array one by one. So it examines each element, and then it tries to compare whether it found that particular element. Once it locates the value, then it stops. So basically what happens, suppose you have an array of length 10, and in this array you are trying to find, there are multiple numbers out there, comma. I'm not putting the numbers out there, and then there is a number, let us say 100, somewhere on the array. So once you locate 100, suppose you are searching for 100, so your search algorithm should start from here, from 0th element. Always remember that whenever we define an array, our indexing starts from 0. So it starts from 0th element, and it keeps on iterating. Once it finds the element, then it stops. So is there any is there any comment on how possibly you could iterate over the array? I mean, how do you iterate over each of the elements in the array? What is the keyword in C++ you use there? Any comment? You can put your comment on chat box as well. Quick question. How do you iterate over an array? You did it, I think, during your exercise last week, the lab. So, any comment? Yeah, of course. Yep, of course, the for loop. Thank you for your answer. Yes, that's right. That's the for loop. So, for loop is the answer. So, you do a for loop and you iterate over multiple elements. So, what does it look like? I mean, linear search algorithm, what does it look like if you just do it by hand, not by programmatically, but if you were trying to do manually? So, if you have an array, this one, num list, it contains these many elements, right? So, 17, 13, 5, 11, 2, 29, 3. You are searching for 11. So the linear search, what it does, it examines, it runs a for loop in the to start with. Then it examines 17, 23, 5, and 11. So once it finds 11, then it stops. It says that we found it. But then suppose it wants to find 7 out here. Is 7 a part of this array? The answer is no, right? So the linear search will examine all the elements of the array, and the search will be exhausted, and it will say that yes, I mean we searched it, we didn't find this element. So that's basically the essence of our linear search. So algorithm, I mean you can write it in multiple different ways, but it is better always to write it in a program. So let's do some hands-on programming. Let me open the folder and let me, there is a lot of things going on here. So let me go to the folder that I want to put the stuff. So C++, let's see, where is that? No, I want to go to the classwork here, classworks. So I can do, I can go here actually. So let me open this one. So it contains whatever I have done yesterday, I mean during the last class. Let me create a file. So I create a file called let's say linear search.cpp. So what is this? Oh, this is the terminal. Okay, oops, we want to bring it down a little bit. Yeah, here you are. So the linear search algorithm, I mean, what we need to do, basically, we first, I mean, do the thing like include input output stream, IO stream. I mean, that's the normal stuff because you will obviously using input output stuff here. And then you do using namespace std. Then we need to define a function. I mean, uh, the way we are learning the programming, I mean, we should be doing the programming in a modular manner. Like we should define a function always. I hope that you have learned before what is function in your prerequisite course. So function is basically something you can define like a prototype to begin with. Let's say we call it int. We are learning the linear search for the integers for the time being. Linear search, let us say this one, and then we can say that our first we have to pass our array to the prototype function const int. We don't want it to be changed, and then we can do int. That is our signature of the function. I'm giving you what I'm telling you what we actually want to do with this different stuff. So this one, the second one, let's say uh, we can do it like this array. No, not this one. Next to here, we can write array. I can maximize the screen actually. We can write this array, and then here integer, this is actually the length size of the array, and this one is the number that you want to search. Let us say num. So you can define it in this way. This is your prototype function. Now we have to define the real function, but let's say how we can do that. So first of all, let's do a modular approach. So that's why when you write a function, initially you don't care about what is written here. The way we should be coding is that we define a function that, well, our structure of the function looks like this. Now what? So let's define our the main program, int main. Okay, so this is simple, super simple. So main and this, and then we can write return 0. So that is our shell of the program, the bare minimum stuff we need to do in order to write the program. So then comes the uh, harder part. Let's define the size first. Constant integer size. Of course, it's constant integer because your array should be of constant size uh, to make the situation simpler. So that's your size, and then let's define the array. Int, let us say test size, that is the array size equals, let's define arbitrary array, let's say 87, 75. I'm following the book. I mean, whatever they gave in the book, I'm following the same convention. 98, 182. These are the numbers what that we use to form the array. Now, what we can do is that we are searching for a number, so we can say we can define something like int result. Now, this is the result, and then we can say if we search the array for, let us say we are searching for the number, search for 100. So what you do, you just write result equals, and you can say linear search, and then you can pass this number. You can say test. So we can do it tests plural, not the singular number, because it's an array collection of numbers. Tests, and then you specify the size, and then you specify 100. That's the number, that's the magic number you want to find from this array. So if you, I mean, we did not write the program, so it should be like this. It should be constant as well. So I think that way it will be okay. Oh no, that's fine. So I don't know why it is showing some error. Too many arguments in the function call. Constant integer size equals 5. That's fine. I don't know why it is showing some error. We'll take a look. Don't worry about it. So we have the tests. We have the size parameter, and then we have 100, which is basically your uh, number you are searching. So let's now make some progress in writing the function. So the function should be, it shouldn't be hard to implement. So you can do int linear search. Now we are implementing the function. Before here, we have defined the prototype so that we can write this code here. Now we are implementing the function. So we can say linear search and then exactly same type of I mean signature we can put. So one quick point, if we these things, I mean, like when you define the function, you pass several like arguments right here. So when you define the function, uh, these are called arguments, but when you specify these numbers, you can call it parameter. I mean, it's a conventional way to call them. Now you have the linear search. Now what you can do here is you can do int we are trying to run an index. I mean, here you have five elements. So 87 is the zeroth index, 75 is the first index, 98 is the second, 100 is the third, 82 is the fourth. So we have to write an index equals 0, I mean to begin with. Then the position, let's say pos equals, we start with -1. I mean, we don't want to, we initialize it in this way. And then you have to do boolean found. You have found it or not found it? False. You did not find it by default. Now, a quick fact you can see that's related to some basic properties in the C++. You see here, line number 20 to 24, we defined the function. I mean, we have not completed, we have just started defining the function. But you can see here that there are variables like index, it should be index, position, pos, and found. Whenever we define a variable within the function, we have to initialize those. If you don't initialize those, your compiler will not be happy. That will throw you some error. But if you define something in the global scope, you don't have to define a value for it. So for example, line number 11. So this is an important property of the language. Of course, we will later see that it is very tied with how the memory is organized for this programming paradigm. Anyways, let's move forward. Now we have to do a iterative loop. You can do it with a for loop, but we can do it also with the while loop, that they do the same thing. So what is this? We do index less than let us say size, and we can do so index is while index is less than size, so we will be iterating stuff, and then not found until you find it. So I hope that you are familiar with this not operator. So it is equivalent of writing found uh, equals false. You can write it in that way as well. Sometimes some people like it that way. I mean equals way, and there is no right or wrong in this case. Anyways, so we do if array index whatever index we have equals value not the value. We have to do num. That's the value actually. Once you find it, you can say um, found equals true, and then you can say pause the position equals index. So you have to record the position, and then you can just move, do a fast forward. So that way you will do index plus plus, and finally you will return pause position. So what does this mean? Why it is like this? Identifier num is unidentified. How come it is like that? We'll see when we compile it. So anyways, okay. Anyways, we'll see what we can do about it. So we have defined it in this way. We have the linear search. We have a constant integer array. Uh, I don't know why it is showing expected I mean parentheses. Let's see if we miss anything here. Not here. We are good here. We are good here. We are good here. So let's see what it does. So that's it. That's about it. And then we are returning the position. So basically what it does, it runs a while loop. It finds out every number, and then once it identifies the num to be, I mean, once it finds num, one of the index equals num, then it says found equals true, and it returns position. Now uh, this integer, the return type is the position where the number is located, the index of the array. That is the return type. So once you do that, now come here, you can say if result equals -1, that is your default value. If you don't find it is number one, -1, you can say that cout, that is your outputting this statement that um, let's say number 100 is not found, or you can say else here, you can say cout number 100 is found at the index, and then you can say that result plus 1 at this not the index, at the position. Index means basically from 0 to whatever, but this is for the position. That's why you are adding it with 1, adding it to, you are adding 1 to it. So end line. So I believe that's about it. That's our code. So if you do that, I don't feel good about this code because it shows 7 errors. I don't know whether it is due to some local, I mean, this Visual Studio Code stuff or something else. Because in the last occasion, we did not have any such issue. We are experiencing it only here. So what is this, first of all? Expected view problem. Let's see, expected a whatever. Anyway, so let's try to solve this one first. So we can create a terminal. So terminal, new terminal. We have created a new terminal. It comes up here. So we can say G++ dash dash version. That way you know which version it is. It is there. Now what we can do right now, G++, and then we can say dash O, linear search dot exe, and then linear search dot cpp. If you put it there, so you have problem. So what is the problem here? So you have uh, why error is a problem. constant integer. You define it constant integer that way. I see why the problem is. So you should be doing constant integer array maybe. So that looks better. So now you do this in this way here. So that is good. That looks good, and everything got resolved. Yep, that's the problem. I mean, while I was writing a code in C++, behind my mind was the Java. So that's why I made that mess. But anyways, so let's try to run it. Let's see. I want to get rid of this debug totally. Yes. Now let's try to run it again. But again, we have some issue. Why we have some issue? We should not have that issue. So constant. So why it is like, oh, I did not save it. That's the problem. So I have a lot of things going on here. Close all, don't save. Okay. Now I'm going there only. Yes. Now it should be good. So where I am. So this is, I am in the class work. So if I do it now, let's see what is going on. So I made a parenthesis error. So I have to put a semicolon out here. That should get take care of this parenthesis issue. And then if I compile, now it compiles well, no problem at all. And then let me try to give enough space so that we see it where we are running. So here, okay. Now we can do dot slash linear search dot cpp. So we are searching those numbers, and you can see we found, but it did not write anything. How come it did not write anything? So let's see. Is it the output file that causes the problem? Let's do that. G++. So we have a.exe a.exe. If we do that, so yeah, that was the problem. This one got corrupted. Oh, that's the problem, because I was trying to execute this file itself. So let me do it again. So G++-O, this is the output executable, and then I'm putting the linear search.cpp. This is the way dot slash, it is the way the I mean this tool mingw finds a file. So if I do that, then I should be able to see that. Oops. So uh, this one is created 7:31 p.m. So just now we created that, and now we can again write the program. So we can do dot slash linear search dot exe, and if I run it, you see number 100 is found at the position 4. So is it true? Let's see. Let's verify this one. And you can see from this here, 1 2 3 4, you are putting plus 1, so 0 1 2 3, and you are adding plus 1 to that. So at the fourth index, fourth position, or third index, you found this particular uh, uh, element. So that is your linear search. So you have to go through all the elements. Now suppose there is a situation, you want to find out, you are trying to search for, let us say, 1000. It is not there, right? So let us do 1000 here, and then see how it changes the output. It is just to make sure that our code works for any situation. So let's go here and compile it again, and then we can run it. So it is not found. So we are good. I mean, we just completed the linear search algorithm. Any question on this code? Okay. So now let's switch over to the slides again. Let's go to where we were talking about. So this is the code that we wrote it by ourselves, but it is a way. Oh, I think did I increment this one? Let me see. Uh, I should have, but I, In the while loop, yeah, I did that. So that's good. I just forgot about this one. So, this while loop, the structure of the while loop, I hope you are familiar with. But since we are just starting a full semester, so just letting you know, I mean, be careful how you define the while loop. It is very common for anyone. Just write the while loop properly, but then they forget to uh, do this increment. In that case, you will be running infinite loop basically, and you will be confused. At the end of the day, you will be thinking, why, what I have missed? There is no error, there is nothing, but still the program is not giving me any output, and it is running indefinitely. So this is the reason why you are having this issue. So yeah, I mean, it may well be that you know a lot better in the initial preliminary syntaxes of C++, but I want to start slow so that you gather the topic, everyone gathers the topic, and we can make progress on the based on that. So that is it, and then we can now switch to the next topic. I mean, you know, the main benefits of the linear search are, I mean, it is easy, right? I mean, so easy to write the code. The array can be in any order. I mean, you don't have to sort the array. For linear search, you don't have to sort anything. It can be unordered array as well. The disadvantage of linear search is it can be slow. Why it can be slow? Because if you have an array of 1 million elements, okay, think about Amazon shopping cart and you or Amazon customer base or Facebook Facebook users. So you have millions or billions of users. So if you define them on an array, the linear data structure, and try to find it using the linear search, then you have to run, I mean, you have to go through potentially you have to go through 1 million of the records. I mean, your particular record may come just on the top, it may be well at the end, but basically, potentially, in the worst possible scenario, you have to run over 1 million records, which is not very efficient. So, on an average, it will examine n by 2 elements because you have an array of n number of n, size of the array is n. It can be 1 million, I mean, the very bad scenario. So your element can be here in the first array, zeroth element, or your element can be sitting here at the last element. So that is n minus 1, or you may not find it. In that case, you have to run over all the elements in between. So that's it. So that's why what is the average number of time you have to search for it? So 0 plus n, basically n by 2. And then um, so that's, I mean, you have to search for all n elements if um, if the value, I mean, if it is not in the array at all. So that's the disadvantage. Now comes the binary search. Now things are getting little bit exciting. Uh, we are whenever you do the linear search, it seems to me that we are really doing computer science. We are no longer writing some simple programming. I mean, there are multiple designation like people, whoever like you. I mean, for example, you are learning doing the computer science class, so you are not a programmer, so you are a computer scientist, or uh, you are an educated computer scientist. So there is a difference. Programmer means you can follow whatever people ask you, and um, basically without knowing what you are doing, basically. uh, I'm not saying that programmers don't programmer does things without knowing what they are doing. I'm saying that you can do that. I mean, potentially a programmer can know nothing, and they can just do some this framework, that framework, that's it. But being a computer scientist gives you some, I mean, an edge over the programmers, so-called programmers. So why? Because you know why you are writing certain things, why you are not writing linear search. You must say that, well, I mean, I have a, I have 1 million number of customers, so that's why I'm not writing linear search. I'm writing the binary search. So those type of decisions you can make. I mean, programmers can also say that. I'm not saying anything negative about that, but you are learning it. So that's the important part. Now, the binary search, the main requirement of the binary search is you have to sort the array. You know, you have an array like before you had what? You had an array like this one here. This is not sorted, right? This is not sorted. This is not sorted. This is unsorted. But for binary search, you cannot do apply binary search here. You have to sort it first to apply a binary search. So what does it do? So once the array is sorted, you have this array, you know, you have an array like one, two, I hate this mouse writer, three, 4, 10, 90. I mean, arbitrary array. So you have sorted it. Now, next thing you do, you divide the array into three sections. So first section is the, you have to identify the middle element, and then you have to identify the elements on the right one side of the middle element, left side of the middle element, and then you have to identify the elements on the right side of the middle element. So basically you will be like this. I mean, you will locate the midpoint here, midpoint, MP is midpoint, and then you have the elements on the right, elements to the left. So that is the basis of your binary search. Now, if the middle element is the correct value, for example, then you got it, right? It's done. I mean, otherwise you have to go to step one, you know, using only the half of the array that may contain the correct value. You have to continue the steps one and two until you find the right element. So why you are going to step one here? So basically what happens, you suppose you have this one, this guy, this array. Now we want to find 4. Okay. So what is your middle element in this case? Actually, you have two middle elements here. Let's do a simple case. Let's say another value 99. So in this case, what's your middle element? 1, 2, 3, 4, 5. So you have this one. This is the middle. These are the extreme. So you got it. So that's done. Suppose you want to find 10, or suppose you want to find 2. How do you find it? So you identify your middle element. So is it equal to the middle element? The answer is no. So now you compare, it is higher than middle element or it is lower than middle element. Your answer is yes, it is lower than middle element. Then you go to number one, that means you are focusing on this array only. Find out the midpoint of this array. So you got this midpoint. Now you go, now you find 2. So on the other side, other hand, if they ask you to find 99, let us say. So again you start with 4. So it is not 4, 99 not equals 4. So will it be on the right or left? It will be to the right hand side, right? So here in this direction, so there you establish the midpoint, that is 90. Is 90 equals 94? No. It is less than 90? No. Is it more than 90? Yes. So you go there. Now there is no more element, so midpoint is itself 99. I mean, whatever the value, 99, and you found it. So that's how you, I mean, if it's an array of single element, its middle point will be itself. So that's the way you are going to find the going to do the binary search. That's the algorithm of the binary search in a very short, I mean, in a very brief way. So let's do it in this way. I mean, this is simple. You see here, what is the midpoint here? This is the array. So your midpoint is here, and you want to find 11, so you found 11. That's fine. You are finding 7. So what you do here, you go there. I mean, locate the midpoint. 7 is less than that. You go here. Locate the midpoint 3. 7, basically 7 is more than that. You come here and there is only one element. You locate the midpoint, that is 5. 5 is not equal 7, and you can say that, well, I didn't find it. So basically you are running 3 iterations in this case. First iteration is this midpoint, second iteration is this midpoint, third iteration is this midpoint. But if you were to do the linear search, you have to do 1, 2, 3, 4, 5, 6, 7 iterations. So you are gaining by more than factor of 2 in terms of the programming time. So that is the advantage of the binary search. It can find the things pretty simply. So I'm skipping this thing. I mean, this looks a little bit like, what do I say? I mean, little bit wordy to me. So let's go to the program. And I'm not presenting the program from here. Rather, we can go through the program and write it by ourselves. So let's do it here. Let's add a code called binary search, bin search dot cpp. So as usual, we start with the basic stuff. That is your, I mean, your basic, I would say, we start with our, what happened to it? Just a second. Okay, that's not what I wanted. Something popped up. Anyways, so we start with the basic stuff like we define the code, and then first step we do the include statements. Let's copy and paste from the previous thing, like these two statements. We don't need to innovate anything here. So we go there and do the binary search here. That's fine. And now define the prototype int binary search, and then we first define const integer array, then integer size, and then integer number. That's our function. It's pretty standard. Then let's define the main program, right? So main program is like this: return 0. We are good. So now let's do a little bit of let's include a little bit of things here. Let's say we write int tests equals, this is a test, and then we have to define the size, of course. Uh, const int size equals, let's say, 20. Okay, there are 20 is IZE, should be. Size is 20. Now we do the tests, and we do we can do size equals, let's say, I mean, I'm just following whatever is given in the book so that you have absolute correspondence. So 101, let me copy and paste this stuff so that we don't waste time here. So that is about it. And then we complete it. Okay. So now, as usual, let's go to the results. Int result, okay, and that's it. That's the result. Now we have to um, do it. We have to find the number, whatever number we want. So let's say we want to find the number int. Let's say num equals. Let's say we want to find 296. Sorry, what did I do here? 296. That's it. And then we have to simply call this program, but I mean not the not with the full signature, but we have to call like the array first, that is tests, and then the size, that's 20, and number. That's it. That's your signature for the call. And then you can say same way like linear. If you find it, it is found. If you don't find it, it's not found. So you can say if this, I mean, exactly same thing. Nothing needs to be changed except your linear search will be replaced by binary search. That's it. Now we have to write the main program that is called this one. You have to implement this one. So how do we do that? So let's do this, and yeah, now we are in the business. So uh, so what you can do here, so you have to start from the first array of the first element. So we can do int first equals 0. This first is there, and you can say last element is basically your size minus 1. That is your last element. So int, it has to be int. Then you do middle. So you can say int middle. Let's do int pause equals minus 1. And then we can define bool found equals false. So these are the variables we define. Now we have to make sure we put some value to the middle. So first of all, first thing first, we can do while. Sorry, not here. What did I do? Middle. Again a while loop. While we can say not found and first is less than equals last. So then we can say middle equals what? First plus last by 2. That's simple. First plus last divided by 2. That's pretty simple. If so, you can now find if array, whatever variable we defined, middle equals value, not value, it should be the number. Then you can say found to be equals true and position to be equals middle. Okay. Now you may not find it, right? I mean, it may not be like that. You can say if, else if array middle greater than number, then you do this one. Last, if your array is, I mean, midpoint is greater than number, you say last equals middle minus 1. So so your the number that you put in, that number is more than, so you have to go to the right hand side of the array as we discussed before. Here we are, okay. So when you do that, if your particular value is more than the, if your array mid value is more than number, or you can say if your number is like number is less than the midpoint, then you have to go to the left side. So you say last equals middle minus one. So basically what we are doing here, I'm just trying to make you envisioning this stuff. What happened to this? Let's see. Okay. Okay. Now, what is going on here? You have this array, and you found that your midpoint, this was the midpoint, and the number, let's say this is um, whatever the midpoint is, let's say 10. I mean, 10 doesn't occur in this array. I'm just giving you an example, and you want to find 7. So definitely your 10 is greater than 7, right? So you have to switch to left hand side, and in the left hand side what will be your last index? That should be middle index minus 1. That means suppose you have 1, 2, 3 and 4. These are the indexes: 0, 1, 2 and 3. These are the indexes. So your midpoint is the third index. So your last for this particular search would be 3 minus 1 equals 2, this one. So that's what is implemented here. So then what we do, we got that, and then we can say that else, sorry, um, you, last equals middle minus 1. Then you repeat it, you carry on, then you go to the middle. I mean, you can recalculate the middle first plus last by 2 and go through the loop, and finally you say else. If that, if it is less than I mean greater than number, else means if it is more than the number, that is we are going to the right hand side. If that is the case, you can say first element equals middle plus 1. So you are just defining your first element, I mean manipulating your first element and last element. If your search is going towards the left hand side, your first element will remain as first element, but your last element will be replaced by this one. So once you do that, it will, this is a while loop, so it will go to the next iteration, and then it will try to calculate that one. So, and if it is the otherwise, like your midpoint, your number is more than what you have on the midpoint, then you go to this final for number line number 46 else block. And finally, you find it, so you can say return pause. If you don't find it, you don't return anything. So that is our code pretty much. So let's see if I try to run the code, how it works. Any question about this code? So we just, I mean, we just made a conversation in the class and we built the code. That's how we should be working all the times. As a programmer, as a learner, you should be learning in this way. You go to the book, you look at the book and start creating your own story, like write your own code and try to compile. When you compile, like what happened to me in the first time, you will find errors, and that's where the learning occurs. I mean, if you find the errors, you will try to solve it. You will learn how to solve the problem. You will learn the problem. You will learn the solution. So now let us do G++ dash O binary, or you can say bin search dot exe, and then you can do bin search dot cpp. So if you compile the code, you see we have some warning. So what is going on? Control reaches end of non-void function 51, line number 51. What is going on here? So, oh yeah, I mean, I think we should be doing it here. So we should not be doing that here. We should be returning outside this basically while loop. because we will have enough with the uh, like we will have enough with finding the middle point. So basically we should be defining it here. Return pause. Okay. So that's what, I mean, that's what you have to do all the times. You have to write the code and then try to find the right answer. So this one, this compiles and then bin search exe. Now you can see is found at the position one. What is the position one? Let's see. Yeah, I mean, why it is one 296 is found at position one. How come it is position one? So I believe that what is happening here is so we should say 296 first of all. Number, there are multiple things we have to do here. So number, and then we have to say num. That is one thing. Then same thing here, you know, that is first thing. That is another thing. But here we do not worry about the indexes because index, when we do the index, then the problem is so this is your middle. So middle is middle. So you have the it's the what is going on here. Let's see. One and size. So you have this. Did we? Oh, we did not. Did we increment this stuff? We do not need to increment, right? I mean, we are doing the not found. So are we doing found? Found here and first less than equals last. So I'm confused about why I'm getting at the position one. Let's see. Let's run it over again. Let's see what we get. So not why it is. Oh, I think that I'm doing the linear search. Why it is doing that? Because I'm not calling the linear search. There is no number 100, right? So you have the number here. So how am I calling it? This is good. So this is very strange. So let me do one thing. Remove or uh, I can do the other way. So this one, something strange is happening. Dot slash a dot exe, and then we can see number 100. Why the number 100 is mentioned here? So this is num position result equals 1, but then why it is 100? I am very confused at this point. So this is binary search. So this is the bin search. That is good. We are calling the binary search. Um, that is fine. So why number 100 is being called all the times? So are we in the same program? So let's say, yeah, class works. We are in the same position. So why I am seeing number one? Let's say if I do number, making it lowercase, does it even, is it at all taking the new values? No, that's not right. So now if I do number 296 is found at the position 1. So 296 is located. But what about the position 1? Why I am seeing the position 1 that I don't understand here? So you have here first plus last by 2. So because it is always, what is happening, your array, but your array is array. So you have the middle. The middle is always calculated. How come it is finding position equals 1? Let's see what is happening here. Pause. This is pause. This is okay. That's fine. So you are finding it to be at the position 1. Let's see what is happening here. So result plus 1. What is result, by the way? Oh, that's the wrong thing. You should be doing result equals. I mean, that's the reason you always try to write your code by yourself, not reading the book blindly. I mean, book is not wrong, but I typed it wrong. But that gives us a little bit of learning. So this one, and then you can see it's a position 10. You found it at position number 10. So let's verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's where it is. So instead of 296, if I would say 142, let's see, 142, then what happens? We do the similar stuff. We compile it and then we search for it. So position 2, that is right. And let us say we do 600, last position. So it should be at position 20. So if we do that, so position 20, if I put some arbitrary number 690, which is not there, then what happens? So let me raise it a little bit again, and then we can do this one. So it's not found. So I mean, we are working it, we made it to work properly. So that's about your binary search. Any questions so far? So what is the main benefit? Because it's much more efficient than linear search. Just now we have seen that in a much shorter time span, in number of lesser number of iterations you can accomplish. So basically, for array of n elements, you can perform maximum log n. The base of the log is 2, log base 2 n number of comparisons. And disadvantage is you need the array to be sorted first. That is a disadvantage. That adds some cost to the to it. So that's your searching algorithm. That's all about searching algorithm. We have done. We have completed the searching algorithm. So let's do a quick 5 minutes break, bio break or anything, and we will come back and in 5 minutes. So let's plan to come back around 8:11, and we will complete the sorting algorithm. Them alphabetically. If it is a numeric, you order them either ascending or descending. Now, for our class, we will be considering only two sorting algorithms. Number one is bubble sort and number two is selection sort. We are going to discuss about those. So let's see what are those. So bubble sort first. So the bubble sort is kind of I mean like you you have number of elements in an array, right? You have one, let's say 1, 10, then 5, 3, 11, 9. So this is unsorted array. So bubble sort, what it does, it compares first two elements. So in this case, it compares these two. Now, if it is out of order, let us say we want to do natural ordering, I mean, like increasing order. So compare 1 with 10. If 10 is more than 1, then let's keep it. Then compare 5 and 10. Is 5 more, 10 less? No. So 10 is more than 5. So let's swap. Let's exchange the position. So 5 will be here and 10 will go there. So our array will be 1, 5, 10, 3, 11, 9. So in the single run, we will continue this until we get, I mean, like we'll do multiple flipping and sorting. But one single run may not be sufficient. you may need multiple runs for that because you are comparing first two numbers. Now, this is up to this, it is good, but now you come here, it becomes one. I mean, you compare these two, it becomes 1, 5, then you have like 3, 10, 11, 9, you know. So you keep on sorting those out, but then this is not sorted. So you have to run, you have to start your engine again, over again. If it is sorted, we are good. If it is not sorted, then you have to do it over and over again. So that is basically essence of your bubble sort. So basically you start with this one, num list 3. So here 10, 17, 23, 5, 11. So you compare values 7 and 23 in correct order, so no exchange. You now compare 23 and 5 not in correct order, so exchange them. So so basically what happens now? It becomes, I mean, this becomes 5, this becomes 23. Now you move forward, you compare 23 and 11. This is not correct order. So you get at the end of the day 17, 5, 11, 23 because you are also swapping this one. But this is also not quite sorted, right? So that comes here 17, 5, 11, 23. So this is not sorted yet. So compare values of 17 and 5, not in correct order. So we have to exchange them. So we get 5, 17, 11, 23. So now compare 17 and 11. So you get 5, 17, 11, 23. Now compare 17 and 11. You get 5, 11, 17, 23. Now compare 17 and 23, they are in correct order, no exchange. So now you can see that you have completed the ordering, right? So after the second pass, you have this one. Now what you do, you just compare 5 with 11, they are correct. 11 with 17, no swapping necessary. 17 with 23, no swapping is necessary. So you have to, um, after the third pass, you conclude that it is, I mean, if there is no more exchange, you conclude that it is sorted. So that is the essence of your bubble sort. Any question for that? So let's try to come up with a program for the bubble sort. So let's uh, let's do it in this way. Sorry, what happened? So here, let's not this one, not this one. We want to do. We can go here. So now this is not the one we want as well. So what is this linear search, binary search? So now we can do create a new file called bubbleshort.cpp. Okay, so that's pretty standard. Um, so let's do it in this way. So you have, so let's do input output stream first. I mean that's the standard stuff, and then using namespace std. Okay. So now what we do here, we do we are using the strings. We can using the strings. I mean whatever we want to do. So let me see. We want to sort the stuff. So, so we don't want to do that in this way. Just a second. So we want to sort some numbers. So that's how we do a bubble sort. So just a second. I'm just trying to get our code. Yeah, that's the one. So let's do it the code in the book. Let's do it line by line. So, oops, not, I don't want this. Let's don't save it. So we can bring it here. So let's write the code. So you have that and you have using namespace std, that is fine. Now you can do like void bubble short. That is your function prototype. So you can do int array and then you have the int. I'm telling you what that's the size basically. And then for the bubble short, what is necessary was a swap, some swapping facility. So we do void swap, we do int, let's say a. We are using the pointers because that's how we will be, because you have to follow through the values in the program. So let us do it and then we will keep on illustrating the stuff. So we do main program now, and then of course return 0. That is graceful. Now if we start the programming, we would write const int size equals, so this should be int size. So int size equals, let's say 6. We are sorting 6 numbers. That's it. So int tests, again a few numbers, that is tests, and then size equals 6 1 5 2 4 3. Okay, so now what we can do, we can display the unsorted value first. We can do cout um, unsorted numbers, you know, just writing it down. And then what we can do here, uh, we can, what is this? Yeah, that's fine. So what we can do here, we can just write a for loop for uh, auto element. Now, what is auto? I mean, refer to last week's lecture. We talked about auto. So this one, we do cout element, and that's it, you know. And then we can do like we can do end line as well. So line by line, we are going to print the elements. That's it. Now we have to sort. We do bubble sort, and then we have to refer tests. That's the array and the size. What is the size of the array? And then we can say same thing. Um, this one, this way we can say um, sorted numbers, and we can say same thing. The tests. That way things will be sorted. So that's about it. So that's the program. Now we have to write the main program, which is the bubble sort. So it should not be very stressful. I mean, it's simple. So let's write void bubble sort, and then we can say like we can reuse the signature like this here. So let's get rid of the semicolon, and this is the body of the program. Let's say we write now max element. That's the maximum element we find. I mean, we were comparing two, right? And then we do index. that will be the running number. So now we can do for loop, you know. Um, what we are going to do here is that we will be just so there are two sets of numbers here. One set we will be like here, let me do it. Not two sets, I mean, there is only one set of number, but let me draw another board. So here you have to do multiple passes. So you will start with from the end, one side, you will start, that is your first for loop, and from beginning, that will be your second for loop. So what you can do here for max element, that is the maximum element, equals size minus 1. That's quite obvious because that's at the end, to the end. Um, max element greater than 0, max element minus minus. So now within this, what you should do, you should run another for loop because you have to run multiple passes, right? So you do int index, like you don't need to define int, you can do index equals 0, index, because at the end of everything you are you leave with a new array, right? Like we showed you during our manual sorting technique, manually when we implemented the bubble sort, and then we do index plus plus. So here what you can do, you can call the swap function. So whenever you I mean our greater than I mean natural ordering logic will be contained in the swap function. So we will be calling the swap function, and we will pass these values array index, and then the second value will be next value, that is array, not array, it should be array arr index plus 1, the next index. That's it. So at the end you should, and there is nothing to be done because you are swapping, keep on swapping, and if you find something bad, then only you swap. So that's why we have to write the swap function properly. So the swap function is like this one. So what you do here, void swap int pointer a, int pointer b. So that's your signature, and you write here int temp equals a. Now you said a equals b. Now you can say b equals, I mean b equals temp. So you are swapping basically. That's the standard way of swapping stuff. So I think we are done with this one. So now if we compile it, let's save it first. And then after saving it, so what we did here, we defined these two functions, I mean these two methods. Then we defined the main method, and we just printed unsorted numbers, and then we printed sorted numbers, and in between that we call the bubble sort without even knowing what bubble sort, how we are implementing. Now we are implementing it, and we have to write a nested for loop for that. It's like that. And then we can go to the swap. I mean, this is the swap function, and that's it. That's our bubble sort. So uh, there is a mistake, you know. I thought you would ask me that question actually. That's why I started repeating it. So what you have to do, you have to compare, right? You have to do ARR, then you do index is greater than ARR um, index plus 1. If that is the case, then only you do the swapping. Otherwise, you won't do any swapping at all. So your swap should be inside this comparison. So you do it here, put it there, and just that's it. That's our bubble sort, because if your first index is greater than second index, then only you swap. Means in this case, I mean, if you have this situation, uh, 5, 1. So you see, first index is greater than second index, then you swap. Means 1 becomes 5 becomes 1 and 1 becomes 5. So your indexes will remain the same. So this is 0, this is 1. Only thing is that the value that is placed inside those indexes, they will be exchanged. That's it. So this is your program. Now let's try to run it. So before running, let's clear the console. You can do it by typing clear there. So now let's compile it. So we can do bubble sort. So minus o exe, then we can say bubble sort dot cpp. So code compiles and then you can do bubble sort. So what is happening here? Why it is what it is looking for? Why it is stalled here? Let's see. So you should at least be able to see this one, right? Size. So what's happening here? Oh, that's wrong. It should not be .cpp. It should be bubbleshort.exe. You know. So then you see the unsorted number, the one we inputted, and the sorted numbers. They are a little bit weird. Why do I see these numbers? There must be some error somewhere. It should not be like that. Um, let's see. So you have the sorted values. So you do the same thing, the um, element tests element. That is good, but here also it is good. But here, what is happening? 3, 4, 2. But we are breaking somewhere. Somewhere the code is broken. So let's pinpoint that part. So you have max element index. So max element equals size plus 1, which is about right. So that is good. So you have the array, you have the size. So are we passing it properly? We are passing the array tests, this one, and size. So there is no problem there. So we have it here, and then um, you do that greater than 0, um, and then you do max element minus minus, and then for index equals 0, index less than max element, index plus plus, that is fine. If you say index equals array index equals I mean greater than index 1, then you do that and you call the swap. So let's see array index 1. And what about the swap? Um, the swap function we do in this way. Temporary equals A equals B, and B equals temp. Then there is nothing wrong here. But how come we are getting that bad result? So we have here the bad result is here. You see 3, 4, 2. 3, 4 is fine, but then it is completely broken. 2, 5, 1, 6. So it looks like it did not go through the final pass. So let's see. I mean, so every time we are swapping over the maximum size, so you have the max element less minus minus, so you have index equals 0. So you have index less than max element, you have index plus plus. Then you have this one, index greater than array index plus 1, which is good. This is index, so this is okay. And then you do the swap array, this one. Something is wrong somewhere. Some definition, something is wrong. So you have the tests. So here array, that is fine. Test is being passed to the array. Size is size. So you have the max element defined. So size minus 1 greater than 0. That is about fine. Max element minus minus, you do index equals 0 index. So that's about it. So we have some problem here. Somewhere we have some problem. Let's see. Let's see the slide. So we have it here. So we did it exactly same way as our slide. So what did we do wrong here? Size minus 1. Yeah, that's what we did. Array index. I mean, it's array because we defined it as an array. We did ARR, so that is fine. Greater than this one. Then we do date swap, and then the swap is basically this one. So you have we have A equals B, B equals temp. So swapping works fine. Only thing is that I guess we have something wrong here in this part. Number of elements there. So we have the max element, we have the index. So bubble sort has some issue probably, possibly. So let's see it again. Um, oh, maybe I did not uh, save it. Is that the problem? So if I again, if I do it, then we do bubble sorters. Yeah, now it is good. So basically, I did not save it properly. By definition, the Visual Studio Code saves the code in multiple iterations. I mean, if I just write something, it's automatically saves something. But finally, I did not save the final code. That's why it was error. I mean, it was giving some error. Now this should be fine. So this is our unsorted array and this is our sorted array. So this is our code. Um, I mean, in your hands-on assignments, the labs, you have the similar problems. You will solve the similar problems. So you can basically go through this recording and just follow this and just do it yourself. Any question here? Let's move on to the next part, which is, I mean, okay, of course, the benefit, it is it is easy, right? I mean, we understood it pretty easily and we implemented it without any problem. Disadvantage is it's very slow because you have to go through multiple passes. More number of passes, there are for each pass there is a nested for loop, which is very inefficient. So next thing is the selection shot. This is the last one. So the concept of the selection sort is basically you sort things in ascending order. For example, then you locate the smallest element in the array. Okay, so you have an array like this, one, let us say 7, 1, 8, 2. You locate the smallest element 1, put it at the position 0. So you do 1, 7, 8, 2. Locate the next smallest element. So this one. So 2, right? And you put it in the position 1. So 1, 2, 7, 8. Locate the next smallest element, 7. No change of the position. So final element is 8, so it is sorted. So this is how your selection sort works. So again, you start with, let us say, 6, 2, 29, 15. So here you start with, I mean, you find the minimum of this everything. So you end up with 2. Put it in the 0th position. Then you have only 6, 29, and 25, 15. Find out the minimum. You put 6 in the one position 1. Then you eliminated this. Now you find the minimum of these two, 15. You put it in the third position, 15. So you are left with just one, you put it final position. So your array is sorted. This is your, algorithm. That is how you are doing it. So basically, let us write the code. I mean, that will be more exciting if we can write the code and just illustrate it using the code. So let's do it. So um, where is my VS Code? Here. So let's create a new file called selection short, SEL short, cell short, CPP. Okay. So first thing first, your input output stream, let's put it together. Now we can define the function prototype void cell short. I'm just writing cell short. I mean, it should be selection short. I'm just writing it like that. We can do int like array and then size, right? Int size. This is your prototype. And then again, um, I mean, you are doing uh, some swapping. Int swap, int pointer a, reference a, int reference b. That's your swap function. Start your int main. So what we can do, we can basically borrow the main code from here. So up to this point, we can cut and paste here because everything is same except you have to write selection short, cell short, because we are sorting stuff. Cell sort. Now we have to come up with the selection short algorithm. But again, the swap will be the same. So let's copy the swap. There is nothing in the swap. So where is the cell short here? So let's go here. Let's put the swap together. Now we can start writing the selection short program. Why it is cannot overload function? What is going on? Oh, this is void. It should be void, not integer. So that's it. Yeah, we are good. Now we can do void cell sort and then we can do int array int size, right? That is it. Now, how do we do that? Let's define first two integers like int minimum index and int minimum value. Okay. So now let's start a for loop. For So we have to find out the minimum of for each iteration. For let's say int start equals 0, start less than size minus 1, start plus plus. That's pretty simple. That's our for loop, standard for loop. Now we can do inside it what we can do. Mean index, your minimum index is start, right? And your mean value, you call the mean value to be the first value. That is your, and that's the finding minimum basically. This is the way you find the minimum array start, right? Now we run another for loop for int index equals start plus 1. Sorry, yep, that's fine. Index less than size index plus plus. That's how we will be iterating again. So basically what we are doing, we are starting with 0. We are calling the first element to be the minimum. Then what we are doing, we will compare, we will start a for loop for remaining values. So we start with one. Let us say you have four values, four elements in the array. We start with the first one. We call it minimum, and then we go to the remaining three. We will compare this value with the remaining three, and if this stands to be minimum, we call it minimum. Otherwise, we will find what is the minimum value. So it's a standard algorithm to find the minimum. So let's continue with that. Mean value equals. So we can do, oh, sorry, not this one. So we say if array index, you know, that particular value that we start with is less than mean value, you know, if you find anything that is less than this guy, you call mean value equals that value. You update the mean value, sorry, mean value, and we say it to be equal to uh, array index, right? And we say mean index equals the corresponding index. So you are keeping an account of the index as well. We continue that, and then finally what we do, uh, once that is done, that once that part is accomplished, we will swap, you know, array mean index with uh, array start plus one. Sorry, start. That's it. Sorry. So that's it. So that's pretty much it is. So we have completed the code. Now swap is also written. I mean, we basically copied and pasted it. So now let's try it out. One thing, we have to save it first. We did not do it last time. So we do here G++ dash O um, cell sort CPP. We have to do cell short dot exe, cell short.cpp, and then if we compile it, it compiles dot slash cell short dot exe. So yeah, again it is sorted, and this is unsorted, this is the sorted. So this scheme worked. So that's about your selection short. Any question about this code? So we got two different sorting algorithm here. So once we are done, what are the benefits of the selection sort? That is, it is more efficient than bubble sort because you don't have to go through the passes, right? The disadvantage is it may be a little harder than bubble sort, but you know it is not really hard algorithm. It's a simple one as well. So sorting and searching vectors, that's what we are not going to do because you know the vectors can be basically vectors can be handled in the same way as the arrays because you do vector v dot at I function at function. That way you will easily be able to convert it into an array, and you can apply the sorting and searching algorithms to that. Now, uh, if you think about the STL, the standard template function with the vectors, you will find a lot of sorting algorithm is already there for the vectors. That is why when you are tasked to do some sorting and searching stuff, you can always convert your array into vector, and you can apply those inbuilt sorting or searching algorithm to that vector. And then after sorting and searching, you can get back your arrays from the vector. But I mean, basically, long story short, this thing, the vectors can be handled exactly the same way as array. So you have the uh, I mean, you need slight modification to functions to use the vector arguments. So basically, you can do in this way, and no need to indicate the vector size because you can use the function, the vector. There is a member function called size. So basically, I would say it is your homework. I mean, not really homework because you have the labs to do. But I mean, since I have worked out all these initial programs, you can go through the lecture and then you can come up with your own sorting and searching for the vectors. So that is kind of thing you will do while you are learning stuff. Let's see. So that's about it. That's what I wanted to present today. Let me go over quickly the lab assignments so we know exactly what is uh, what is on our plate for this week. And if you are stuck with any of the lab assignments, do not hesitate to reach out to me. We can always schedule an office hour and we can talk about those labs. So let's see the course and then we can go to the lab. So let's see lab number 2 here. So you have like a lottery ticket buyer purchases 10 tickets away. So I mean it's a so basically you have to do linear search for these numbers. So you have to search particular number, 5-digit number. You have to search for it, and then two identical arrays, just 8 integers. Each should display the content first array, then call a function to sort the array using an ascending order bubble sort. So you know the bubble sort. You can just write your code in that way, I mean the way I demonstrated in the class, and then simply pass your array there. Next, the program should display the content of the second array and then call a function to sort the array using ascending order selection sort modified to print out the array content after each pass of the sort. So the difference is in the like bubble sort or selection sort, what you are supposed to do in this particular exercise at the end of each of the iteration. So uh, let me tell you long story short, here it is. So we did it here, right? Selection sort. So here, what is the ask here is that you have done this. Now, after you swap here, write a for loop, basically. I'm not writing it, I'm just pseudocode. Just write a for loop and specify your like what is the value, how does the array look like? You can say that array after start equals 0, or I mean you can say like after the value of start, I mean whatever the value comes after the value of 0, value of 1, 2, 3, etc. Similarly for the bubble sort, you have to just write, I mean create the array, I mean just print the array using a for loop uh, at the each step, each pass. So after this step here, you can simply print your array. That way, we will be able to understand what is going on with the array, what are the steps it is going through. So those are the two lab assignments, I would say. But you know what you should be actually doing as well, that you pick up a vector and try to apply the sorting function on the vector. So I mean, what I would say that if you keep that, I mean, if you do that and just save it somewhere at the end of the course, depending on how much, what type of grade is going on, we may have some extra credit. I mean, these assignments will be counted as an extra credit because at that point I will ask you that turn me in whatever extra stuff you have done, you will get maximum this amount of extra credit. So that will be a new opportunity to score some extra credit. So my point is just go ahead and create a vector, like create a uh, sorting or searching algorithm for the vector. So follow the same process as arrays, but just you don't need to put the size because vectors can be easily treated as an array. So just I mean, do the coding, do the hands-on, engage to do the hands-on coding, and that way it will be much easier. So any final thoughts, final questions? Do I need to modify the pacing anywhere? Do I need to speed up? Do I need to slow down? Anything like that? So yeah, I mean, if there is no more questions, let's call it a day. And I will talk to you in the next week, unless I hear from you. I mean, you are more than welcome to reach out to me with your questions. And if you want, we can jump into a Zoom session again and do some hands-on, work out some hands-on problems, your lab problems. I can help you. I won't be solving those problems for you, but I can help you to solve those problems. Let's put it in that way. So that's about it. So if no more questions, let's call it a day and talk to you in the next week again. So what is the question? Need use a for loop. Need on line 17. So what is the question? I didn't follow that. Did you save? What do I need to save? I don't know. So anyways, I will be uploading the video of this session and we'll be talking pretty soon.